today's video we'll be discussing Ohm's law, V equals IR, voltage equals current times resistance. The scientific unit for voltage is volts, for current is amps, and for resistance is ohms, often represented by the Greek symbol omega. As you can see from these three equations, the rearrangements of Ohm's law, this middle one, as you increase resistance, you decrease current, and as you decrease resistance, you increase current. And it is this phenomenon that will be the main focus of our educational video today.
Alright, here we have an example of Ohm's law. When dealing with Ohm's law, you'll have two different kinds of circuits. One is the parallel circuit, and the other is a circuit in series. In order to find the total resistance for a certain circuit in series, you'll add up the resistance from each resistor in order to obtain the total amount of resistance in the circuit. Okay, so here, since we have 5 ohms here in this resistor, we just add it with the second resistor, which is 6 ohms, which equals 11 ohms, which goes up here with our 11 ohms. So, and then coming from our original Ohm's law formula of V equals IR, we're able to obtain the current, which is I equals V over R. Okay, our V right there is 10 volts divided by our R, which is 11 ohms, equals 0.909. I don't know the
Amps.
yeah, amps. Either way, we can. Here we have an example of a parallel circuit. When attempting to find the resistance in a parallel circuit, you simply take the inverse of each resistor and add them up, and then take the inverse of that answer, and that'll give you your total resistance. Okay, so here we have 5 ohms. Oh, we have to take the inverse of that, so it'll be 1 over 5 plus 1 over 6 ohms equals our answer to the -1, which is the inverse. So our answer for this particular problem comes to 2.73 ohms. And that gives us our resistance, our total resistance for this particular circuit. And now in here, in order to find the current through this circuit, it is I equals V over R. Okay? Our V is still 10, and our R now is 2.73. Okay? So, sorry, don't know that on the top of my head.
I'll edit it. Take your time.
Alright, and our total comes to 3.66. Our current comes to 3.66 amps for this parallel circuit.
Alright everyone, I'm going to show you an example of Ohm's law using a series circuit. So right over here we have a 9-volt battery. We have our positive and negative leads coming out. So for now I'm going to connect the positive lead to our circuit board, and we're going to use an LED to show whenever you raise resistance, the LED will be very dim, compared to when you have a low value of resistance, the LED will shine bright. So I'm going to connect the positive side of our LED to the positive lead, and the negative on a separate line of the circuit board. I'm going to take 2 resistors, one valued at 1K ohms, and then another one at 100 ohms. And then from the other side of the resistor, I'm going to connect our negative lead. And this will allow the electron flow through the negative side. The conventional flow goes to the positive side. And with this simple switch here, once I press down the red button, the LED will light up. So, by Ohm's law, if I take these 2 resistors out, total resistance, and I take an equal amount of resistance in one resistor, hook it back up in series, the LED should show the same brightness as before. Now that we've already reduced our series circuit down to 1 resistor, by Ohm's law, if we raise resistance, this LED should be very dim. So I'm going to remove our 1100 ohm configuration and then add a 3.3 K ohm resistor. Hook it back up in a series. And this should show our LED being very, very dim. That's it.
Hello guys, my name is Hartley and I will be continuing with the video. So whenever you have a black wire, it will produce a negative charge. And whenever you have a red wire, it will produce a positive charge. So whenever you connect the red wire and the black wire to the resistor, you will get a light being created if you press the button. So by Ohm's law, if you have the same amount of resistance coming from the resistor to the series, you will be able to create the same amount of light being given by the LED.
Current is the rate at which electrons flow through a conductor. As the current flows through the circuit and goes through the resistance, the rate of the flow of the current decreases. The resistance causes the disturbance in the flow. This causes the light to become dimmer than what it actually would be without the resistance. But if there were no resistance at all, there's a chance that the bulb might blow up. That's why resistance is necessary.